Hello everyone. In this tutorial I will complete solving the exercises of lesson 3.1. We reach number 16. 16 and 17 find the equation of the tangent line to the graph of f which is parallel to the given line. This is the line and this is the equation of the graph. At the point of tangency, the slope of the tangent line equal to the slope of the function. Then we find the slope of the tangent line from this parallel line. Rewrite is as y equal to 3x plus 1. Then the slope of this line is 3, equal to the slope to the tangent line of the function at the point of tangency. The slope of the function, we can find it from the derivative of this function, 3x power 2. Then the slope at the point of tangency of the line, of the tangent line, equal to the slope of the function. Therefore, 3x power 2 equal to 3. Then x power 2 equal 1. Then x equal to negative positive 1. This is the x coordinate of the point of tangency. To find y coordinate, substitute x in the function. F of 1 equal to 1 cube plus 2 equal to 3. The first tangency point is 1, 3, and f of negative 1 equal to negative 1 cube, negative 1 plus 2, 1. Then the second point of tangency is negative 1, 1. Now we have a slope and we have the point of tangency. We can find the equation of the tangent line. The first equation, y minus y1 equal to the slope x minus x1. Y minus y1 3, x minus x1 1. Y equal to slope, the slope is 3 equal to 3x minus 3 plus 3. Therefore, the first tangent line has the equation of 3x. The second tangent line, y minus y1 equal to the slope 3x minus x1 plus 1, negative 1 plus 1. Y equal to 3x plus 3 plus 1, y equal to 3x plus 4. This is the second tangent line to this graph, which is parallel to this line. Question number 17, the same steps. We find the slope from the line, rewrite it as 2y equal to negative x plus 6. Then y equal to negative 1/2 x plus 3. Therefore, the slope is negative 1/2. The slope from the equation at the point of tangency, find the derivative of this function. F, rewrite it as x to the negative 1/2. Therefore, f prime of x equal to negative 1/2 x to the negative 3 over 2 equal to negative 1 over 2 x power 3. Negative 3 over 2 move it to the denominator. It will be x to the 3 over 2. X to the 3 over 2, it means square root x power 3. Now, negative half equal to negative 1 over 2 square root x power 3. Then 2 with 2, negative with negative, x power 3 equal 1. Then x power 3 equal 1, square root both sides. This means x equal 1. Now, the point of tangency, substitute 1 or the function 1 over square root 1, 1 by 1. Y minus y1 equal to the slope negative 1 half x minus x1. Therefore, y equal to negative 1 half x plus 1 half plus 1. The equation is y equal to negative half x plus 3 over 2. Question number 18 to 20, identify the graph of the derivative of each function. We have 4 graphs of function and 4 graphs of their derivatives. Match each function with its derivative graph. For the first function, we have a linear function. The graph of the derivative of linear function is horizontal tangent line, either over x-axis or under x-axis. If the slope is positive, then it is over x-axis. If the slope is negative, then it will be under x-axis. Now, the graph of derivative of this function is b. The second function, it is a quadratic function. The graph is decreasing from negative infinity to 0. Then the derivative should be under x-axis from negative infinity to 0. We have this function, this graph and this graph. At 0, we have a horizontal tangent line to the graph. Then the graph of the derivative should intersect with x-axis. This graph is not intersect, but this graph is intersect at 0. Then, and from 0 to positive infinity, the graph increasing, then should be the derivative, the graph of derivative should be over x-axis. Then the graph of this function is d. The graph of this function is, as you see, increasing from 0 to positive infinity. Then the derivative of this function should be over x-axis. Over x-axis, it is this graph and this graph. But since the domain of this function from 0 to infinity, then the graph also should be from 0 to infinity. Then the graph of this function is A. The last graph is for absolute value function. Since the function is not differentiable at 0 because it is sharp point, then also the derivative should have no derivative at 0, like this function. It has no limit, then it has no derivative. Therefore, the graph of the last function is C. Question number 22. The tangent line of G at the point 5, 2 passes through the point 9, 0. Find G of 5 and G prime of 5. At the point of tangencity, the point belongs to the tangent line and to the function. Since the coordinate here is 5, 2, therefore G of 5 is also 2 because 5, 2 is the point of tangencity. Therefore, G of 5 equal 2. To find G prime of 5, we must find the equation of the line and find the slope. Then the slope of the function at the point of tangencity equal to the slope of the line. We have 2 points and we can find the equation of the tangent line. Find the slope first. y2 minus y1, 0 minus 2 over x2 minus x1 equal to negative 2 over 4 equal to negative 1 half, equal to the slope of the function at the point of tangencity, then G prime of 5 equal to negative 1 half. Question number 23. The tangent of the function h of x at the point negative 1, 4 passes through the point 3, 6. Find h of negative 1 and h prime of negative 1. H of negative 1 is equal to 4 since at the point of tangencity the value of x is equal. The point of tangencity is belong to the tangent line and belong to the graph. So negative 1, 4 belong to the graph h of x, yes. Then h of negative 1 equal 4. To find h prime, we must find the equation of the line. The equation of the line, first we want to find the slope. y2, 6 minus y1, 4 over x2, 3 minus x1 plus 1 equal to 6 minus 4, 2 over 4 equal to h of prime of negative 1 equal to the slope of the line at the point of tangencity equal to 1 half. Or we can directly, since 1 half is the slope of the tangent line, then it is equal to the slope of the function at the point of tangencity. Question 24, 25. Sketch the graph of the function f of x. This is the function f of x. For question number 24, the graph is horizontal tangent line, then its derivative is 0. Therefore, the graph of this function is x-axis is equal to 0, y our f prime of x equal to 0 or y equal 0. For the question 25, the graph of this derivative of this function is a quadratic function. Then the graph of this function is a straight line. Since from negative infinity to 0 the function is decreasing, then the graph should be under x-axis, and since at 0 the function has horizontal tangent line, then the derivative should intersect with x-axis at the point 0. After 0, from 0 to positive infinity, the function is increasing, then the graph should be over x-axis. Therefore, the derivative of the graph of this function is a straight line, looks like this with positive slope. Question number 26, sketch the graph of a function f so that the values of its derivative are all negative. To be the points or the values of its derivative or negative, it means the function is decreasing everywhere. So we can choose this function. This function is decreasing from negative infinity to positive infinity. Therefore, the value of its derivative, it is all negative. It is under x-axis. Since from negative infinity to 0, the function is decreasing, then it is under x-axis, and since at 0 the function change from concave to convex, then at 0 the derivative should have a horizontal tangent line. Therefore, we have a function like this. Also, from 0 to positive infinity, the function decreasing is under x-axis. Question number 27 and 28. The limits define f prime of c. Find f of x and c. If we compare this limit with the limit of the derivative f of x plus delta x minus f of x over delta x, since this limit is derivative of f of c, then f prime of c will be c plus delta c minus f of c over delta x. Then c plus delta c is 1 plus delta x, therefore c equal 1, and 5 minus 3, 1 plus delta x is the function f of c plus delta c, then f of x should be 5 minus 3x. This is for the first function. For the second function, this value is c plus delta c, then c equal to 6, and f of x equal, this is f of c plus delta c, it means f of x equal negative x squared. Change 6 plus delta x with x, the function will be negative x squared. Question number 29 and 30. Find the function satisfying the given condition, then sketch the graph of the function. For the question 29, f of 0 equal 2 and f prime of x equal negative 3. Since the derivative is a constant, then the function is linear with the slope equal to negative 3 and y-intercept equal to 2. Therefore, the function satisfy this condition is negative 3x plus 2. Question number 30, f of 0 equal 4 and f prime of 0 equal 0, and f prime of x less than 0 for x less than 0, f prime of x greater than 0 when x greater than 0. If we want to sketch the graph of the derivative of this function, f prime of 0, 0, this is mean 0, 0 belong to the graph of the derivative of function. When x less than 0, from negative infinity to 0, f prime of x is less than 0, then it is under x-axis. Where from x greater than 0, from 0 to positive infinity, f prime of x is greater than 0, it is over x-axis, then this is the graph of the needed function. The graph of the function should be 0, 4 belong to the function. This is 0, 4. The derivative from negative infinity to 0 is under x-axis, therefore the function should be decreasing. At 0, the derivative is 0, then the function has a horizontal tangent line. From 0 to positive infinity, the function is over x-axis, the derivative of the function is over x-axis, then the function is increasing. So we can write the equation of this quadratic function, f of x equal to x power 2 plus 4. If we check this function, the derivative of this function is 2x. 2x is less than 0 when x less than 0, and it is greater than 0 when x greater than 0, and f of prime of 0 is 0, and f of 0 is 4, therefore satisfy all conditions. Question number 31, write the equation of the two tangent line to this function. This is the first tangent line at the point 1, 3, and this is the second tangent line at the point 3, 3. We want to find the equation of these two tangent lines, and tangent line intersected at the point 2, 5. Therefore, for the first tangent line, we have 2 points lies on it, 1, 3, and 2, 5. For the second tangent line, we have 2 points, 3, 3, and 2, 5. To find the equation of this line, find the slope first. 5 minus 3 over 2 minus 1. 2 over 1 equals 2. The slope of the second tangent line, 5 minus 3 over 2 minus 3 equal to 2 over negative 1 equal to negative 2. Y minus y1, 3 equal to the slope 2x minus x1, 1. And therefore the first equation is y equal to 2x minus 2 plus 3 equal to 2x plus 1. The second tangent line has equation of y minus y1, 3 equal to the slope negative 2x minus x1, 3. Y equal to negative 2x plus 6 minus plus 3. Y equal to negative 2x plus 9. Question number 32. Suppose that f prime of c equals 3. Find f prime of negative c in each case. If f is odd, then f prime is even, and f prime of negative c equal to f of c equal to 3. If f is even, then f prime is odd, and f prime of negative c equal negative f prime of c equal to negative 3. Question number 33. Use the figure to answer this question. This graph is for g prime. Use it to answer, to find g prime of 0. G prime of 0 is negative 4. G prime of 3 is 0. What can you deduce about g if g prime of 1 equal negative 8 over 3? G prime of 1 equal negative 8 over 3. It means it is the derivative is negative, then the function is decreasing at x equal 3. The function is decreasing at x equal 3. What you can deduce about g if g prime of negative 4 is positive 7 over 3. Since g prime is positive, then the function is increasing at x equal negative 4. Is g of 6 minus g of 4 positive or negative? Since this is g of 6 is positive and g of 4 is also positive, then the function is increasing. It is mean that g of 6 is greater than g of 4, therefore the function is positive. Therefore the value of g of 6 minus g of 4 is positive. Can you determine g of 2? We cannot know the value of g of 2 because we don't have the function, and the value here we know it is negative, but we can know that the function is decreasing at g of 2 at x equal 2, but we cannot know the value exactly at this point. Question number 34 to 36, find the value of x where f is differentiable. 34, f of x equal 1 over x plus 1. If we want to use the graph of this function to find where f is differentiable, we see that x is differentiable everywhere except at x equal 1, since x equal negative 1, since negative 1 is not on the domain of the function and the function is not continuous in this function, therefore it is not differentiable at this point. So everywhere except negative 1. For question number 35, as you see, the function has a sharp points at 3 and negative 3. Therefore, this function is differentiable everywhere except negative 3 and 3. For question number 36, also the function has a sharp point at 2. Therefore, it is differentiable everywhere except at 2, because the function is not differentiable at sharp points and not continuous point. Question number 37 to 39, answer true or false. The slope of f of the function f at 2, f of 2 is limit f of 2 plus delta x minus f of 2 over delta x. This statement is true because this is the definition of the derivative of the function, and the derivative is equal to the slope. If a function is continuous at some points, then it is differentiable at that point. It is false because not necessary for a function to be continuous at the point to be differentiable, like absolute value x, this function is continuous at 0, but it is not differentiable since 0 is sharp point. If the function is differentiable at some point, then it is continuous. This statement is true. Every differentiable function is continuous. Question number 40, f of x equal piecewise function equal to x sine x when x not equal to 0, 0 when x equal to 0, g of x equals x power 2 sine 1 over x when x not equals 0, 0 when x equal to 0. Show that f is continuous and not differentiable, while g is differentiable and continuous. For the continuity of f of x, the first condition, f of 0 equal to 0. The second condition, the limit of the function x sine 1 over x when x approach to 0. We can use the squeeze theorem for this function, since sine 1 over x is between -1 and 1. Multiply all sides with x, negative x less than or equal x sine 1 over x less than or equal x. Take the limit for all sides. Limit x approach to 0 for negative x less than or equal limit x sine 1 over x less than or equal limit x when x approach to 0. This limit is 0 and this limit is 0, therefore limit of this function is 0. And since the value of the function equal to the limit, then the function is continuous. If we want to check the differentiability of this function at 0, f prime of x equal to limit x approach to 0, f of x minus f of 0 over x minus 0, f prime of 0 equal to limit f of x x sine 1 over x minus f of 0, 0 over x, x with x, then limit sine 1 over x when x equal to approach to 0 is not exist, since this function oscillating between -1 and 1 when x approach to 0. For the g of x, f of 0 continue. If we want to check the differentiability of this function, f prime of 0 equal to limit x approach to 0, f of x minus f of 0 over x minus 0 equal to limit x approach to 0, f of x, x squared sine 1 over x minus 0 over x, reduce x power 2 with x, then the limit will be x sine 1 over x. This limit, we find it is here, it is equal to 0, and therefore this function is differentiable and the limit exists, differentiable and 0, then it is continuous and differentiable, and g prime of 0 equals, this is g prime of 0 equal to 0. See you next lesson.